Problem 11 from the exam 4 review sheet. The prescriber ordered dopamine hydrochloride at a rate of 3 micrograms per kilogram per minute. There's that special administration rate again. The drug's being administered based upon the patient's weight and time factor, in this case minutes. The patient weighs 121 pounds. The pharmacist sent a solution of dopamine hydrochloride, 200 milligrams in 250 milliliters of D5W. Part A, how many micrograms per minute will the patient receive? We want to start then and find out how many micrograms per minute our patient should receive. This drug is based upon the patient's weight, so that's where we're going to start again. This patient weighs 121 pounds. But the rate that we have requires us to have the patient's weight in kilograms. So that's the first change we will need to make. Now we have the patient's weight in kilograms. Now we can put in that rate of administration, which was 3 micrograms per kilogram per minute. And the kilograms will now cancel, and we have the exact units we want, micrograms per minute. So let's see what arithmetic we can do here. Let's get rid of the decimal again. So that's going to be 10 over 22 when we multiply the numerator and denominator of that fraction by 10. And here's that situation again. 121 is actually 11 times 11. So 11 will divide into 121 11 times. 11 will divide into 22 2 times. So one more division here. 2 into 10 goes 5 times. So what we're left with is 11 times 5, which is 55, multiplied by 3. 3 times 5 is 15. 5 will carry the 1. 3 times 5 is 15. 1 is 16. So the patient should be getting 165 micrograms per minute. Now, part B. How many milligrams per hour will the patient receive? So we need to convert this 165 micrograms per minute rate of application to milligrams per hour. We need to convert micrograms to milligrams and minutes to hours. Well, we've done this one several times, minutes to hours. That's 60 minutes in 1 hour, so that the minutes will cancel. Now we would know micrograms per hour. We want milligrams, so we've got to get from the micrograms to milligrams. And 1 milligram is 1,000 micrograms, so the micrograms would cancel. And we have our desired rate of administration, milligrams per hour. Now let's see what we can do here as far as some simplification. 10 would go into 60 6 times. 10 would go into 1,000 100 times. 5 would go into 120 times. And 5 would go into 165. 5 goes into 16 3 times. 3 times 5 is 15. Bring down the remainder of 1 and the 5. So that's going to go in 33 times. 5 will divide into 165 33 times. Oh, we've got something else we could do here. 2 would go into 6 3 times. 2 would go into 20 10 times. So we have 33 times 3, which is 99. 99 divided by 10. Remember, to divide by 10, all we do is move the decimal point 1 place to the left. So our answer is 9.9 milligrams per hour is the administration of this drug for this particular patient. Now, the last part. If the drop factor is 10 drops per milliliter, what will be the flow rate in drops per minute? Well, we've got to now get some milliliters involved here. And what information did we have there? We're going to be receiving a solution from the pharmacist that contains 200 milligrams of the drug in 250 milliliters. So we probably could somehow factor that in if we work that in with the milligrams per hour that we already have. We know that this drug is to be administered. I think I'll clear out some space here. It's a little crowded. We're to administer the drug at 9.9 milligrams per hour. And the pharmacist is going to give us a solution of 250 milliliters that has 200 milligrams in it. So could we include that conversion fraction? 250 milliliters is going to contain 200 milligrams of the drug, which would then get us to milliliters per hour. And what we desire is drops per minute. So we need to get to minutes, which we've done before. 1 hour is 60 minutes. So now we know how many milliliters per minute, but we want drops per minute, and that's where our drop factor enters in. 10 drops is 1 milliliter. And now we have the exact units we want, drops per minute. Now it's just a matter of doing our arithmetic. Well, what can we cancel here? 250 and 200, they're both divisible by a number of different values. Can we see that they're both divisible by 50? 50 would go into 250 5 times, and 50 would go into 200 4 times. And what about the 10 and the 60? 10 would go into 10 1 time, 10 would go into 60 6 times. Not much of anything else we can do as far as canceling. So we have 9.9 times 5. 5 times 9 is 45. Down 5 and carry the 4. 5 times 9 is 45, and 4 is 49. So that's 49.5, and that needs to be divided by 24. 4 times 6 is 24. 2 times 24 is 48, with a remainder of 1. Bring down the 5, and 24 won't go into 15. So we have approximately 2, and so that would be 2 drops per minute is the flow rate that we want in order to provide the correct amount of drug in the correct amount of time for our patient.